Hi everyone, welcome to Module 7 of Engineering Science N2 called Heat. The topics or the outline of this module. Number 1, we have heat transfer. There is heat value of fuels, linear expansion, steam, that is the theory. When you're doing N3, we'll do calculations as well based on steam. The important terms, you must be able to define heat and temperature and provide the SI units. Heat is defined as a form of energy. SI unit, it is measured in joules. The symbol that is used to calculate heat is capital letter Q. Temperature indicates the degree of heat. It tells you how intense a body is, or it is the hotness or the coldness of the body. The SI unit of a temperature is degrees Celsius or Kelvin. So at the end of your calculations, you can put the small circle and capital letter C, or if the question says calculate temperature in Kelvin, it will be capital letter K. You can be asked to tabulate the difference between the heat and the temperature for 4 marks. It means you need to give 2 points from each side. The 2 points, the first point will be of the definition, heat is a form of energy. You provide the SI unit, you get 1 mark for the definition, 1 mark for the correct SI unit. When you tabulate, you do the table, you write the heading heat, on the other side, you write temperature. You first write the definition and you give the SI unit. So temperature is measured in degrees Celsius or in Kelvin. And the definition of the temperature, it indicates the degree of heat, or it indicates the heat intensity of the body, or it is the hotness or coldness of a body. So you can get 4 marks if you tabulate the difference between the heat and temperature for 4 marks. How to convert from degrees Celsius to Kelvin and vice versa. When moving from degrees Celsius to Kelvin, you add 273. And when you move from Kelvin to degrees Celsius, you subtract 273. So there are 273 divisions between a Celsius scale and a Kelvin scale. You must remember this. You can be given 2 temperatures, water or object substance that is heated from 25 degrees Celsius up to 850 Kelvin. So you cannot calculate the increase in temperature if the units are not the same. So this conversion is important. Heat transfer. Under heat transfer, you must be able to define the specific capacity and provide the correct SI unit. Specific capacity, the symbol used is C. It is the amount of heat energy required to raise a temperature of 1 kilogram of a substance by 1 degree Celsius. So each and every substance requires a certain amount of heat in order for its temperature to increase by 1 degree. For example, water requires 4,187 or 4.187 kilojoules in order for its temperature to increase by 1 degree. But still requires a certain amount of heat, which is not the same as that of water, for its temperature to increase by 1 degree. Each and every substance has its own specific capacity. Now, factors that affect the amount of heat energy absorbed or released by a substance. A substance can gain or can lose heat. Now, the amount of heat that is lost or gained by a substance depends on 3 factors. First factor is the mass of the substance in kilograms. It depends what was the amount of substance. Were you heating 1 liter, 20 liters? So the heat depends on the amount of substance. Number 2, the mass must be in kilograms. If it's given in grams, megagrams, tons, you always change to kilograms. The second factor is the specific capacity, and the symbol is C. Some questions, they can just use SHC for specific capacity, but it's still the same symbol, which is C. Each and every substance has its own specific capacity. So it depends where you're hitting water, where you're hitting the steel. Was it an aluminum? Was it the milk? It depends on the specific capacity. That is the second factor. Last factor, it depends how big was the change in temperature. How was the temperature difference? For example, if you are heating, let's say the same amount of water, 1 kilogram and 1 kilogram, the first amount is starting from 20 degrees Celsius up to a boiling point. The boiling point of water is 100 degrees Celsius at sea level. So the change in temperature will be 80 because it only requires to increase by 100 minus 20. But if the second substance starts at 60, the second substance only requires to change by 100 minus 60, which is 40. So the last factor is the change in temperature. The one that has huge change in temperature will absorb more heat to boil, and the one with the less change in temperature or small change in temperature requires less amount of heat. So it's delta T for a change in temperature. Now, these three factors, as we can see, they affect heat, which is they affect Q. Is directly proportional. Heat is directly proportional to these three factors. If you increase or decrease the mass, it affects Q. You increase or you change the capacity, you affect Q. You change the temperature, you decrease or you increase it, it also affects the Q. So they give us a formula to calculate heat loss or heat gain by a substance. Is Q equal to MC delta T. They affect the heat absorbed by a substance. So is Q equal to MC delta T? It will be provided in exams. The M of this formula is the mass in kilograms. If it's water, water is 1:1. 1 liter is equal to 1 kg. So if you are asked to calculate water in liters, you need to get M first. Then if your M is 20 kg, it will be the same as 20 liters. For water is 1:1. For other substances, density will be given. So you calculate the mass. If you are given 50 liters of oil, you cannot use that 50 liters of oil as kilograms. You must calculate the mass of that oil. To calculate the mass of that oil, we use the formula. Density is given as the mass over volume. Density is the mass over a volume. So when you make M the subject from this formula, you cross multiply, M will be equal to density multiplied by a volume. So you use this formula for other substance. For water is 1:1. C of this formula is the specific capacity. It is measured in joules per kilogram degrees Celsius because it's the heat that is required to raise 1 kilogram by 1 degree Celsius. So it is a constant value. What does it mean by this term constant value? If you are given information and want to calculate heat, for as long as the type of material is mentioned, that is aluminum, it's copper, it's steel, it means that this value will be given. There is a table that is used to get this value or specific capacity. This is the table of constants. So your exam come with a table of constants. So if it is not listed on the question, you will find it in this table. This is the table of constant. All the specific capacity will be listed there. If it's water, you get the value for water. If it is the steam, you get it for steam. If it's the steel, you get the capacity of steel, copper, and so on. So this value will be given unless a question says calculate this specific capacity, type of material. Now, the change in temperature of this formula, delta T, is the change in temperature. And you need to remember that for water, boiling point is 100. A question can say a water is heated from 30 degrees Celsius to boiling point, to a boiling point. So this question does not specify what is the boiling point, but you need to remember that it is 100, which is the second temperature. Now let's talk about delta T. Delta T is T2 minus T1. And T2 of this formula is the bigger temperature. Bigger temperature. And T1 is the smaller temperature. Delta T is a change in temperature. In some questions, you can be given delta T. Some questions you can be given T1 and T2 to calculate delta T. So another name for delta T will be the rise in temperature. If the temperature is increasing, when a question says a rise in temperature may not exceed 20 degrees Celsius, it means you are given delta T. It is not T1, not T2, but it's delta T. A question can also say increase in temperature. Increase in temperature is same as delta T. Now, if a temperature is decreasing or substance is losing heat, the same delta T will be a decrease in temperature. So rise, increase, decrease, change in temperature is the same thing. Same symbol, delta T. T2 is the bigger temperature and T1 is the smaller temperature. So you don't have to worry about this, I've already explained. Conservation of energy. Heat is a form of energy. Energy cannot be destroyed, nor created, but can be transferred from one form into another. Same as the heat. Heat that is lost won't be destroyed, but can be transferred to another substance. So heat flows from warmer substance into a cooler substance until the temperature is the same. And when we write that mathematically, is heat lost by warmer body is equal to heat gained by the colder body. Symbols, Q released is Q absorbed, or Q lost is equal to Q gained. Under Q released, it's MC delta T. Under what is absorbed is also MC delta T of what is cooler substance. Let's have a look at this. Let's say you have the steel that is at 180. This is the steel. Or let's change this to water at 20 degrees. And this is the steel rod at 180 degrees Celsius. So if the steel is cold in this water, the steel is going to lose from 180 and the water is going to gain from 20 until both have the same temperature, which is in equilibrium. And that temperature is T. Since it's common, we can call it T. The formula, heat, law of conservation of heat, states that Q loss, what is lost will be equal to Q that is gained. That is when heat is conserved. There's no heat that is lost. Under what is losing, there are both substances because they have specific capacity. So the formula is MC. We open brackets. We're going to put this to temperature because it's MC delta T. The temperature of what is losing, this is the steel, it's going to lose from here to here. So this is bigger, it will be T2, but the common one, we're going to keep it as T. So for what is losing, it will be T2 minus a common temperature equal to heat that is gained. It will be MC, we open brackets. This is what is gaining. Water is going to gain from 20 to this temperature, which is common T. So it's going to increase from 20 to T. T is bigger. We put bigger first minus smaller. So it will be T minus, this one is T1 because it's a smaller temperature, it's T minus T1. Now, if you take note, this M is for the substance that is losing, the capacity is for the substance that is losing. The temperatures is bigger minus smaller because this one will be bigger than it's going to cool down. So it's bigger minus smaller. On what is gaining, M is the substance that is gaining mass of it. C is the capacity of what is gaining. Temperatures, we always put bigger minus smaller. So for this substance that is gaining, it's going to come from 20 to T. So we put T first minus the initial. What is losing? The common temperature is the second one. On what is gaining, the common temperature is the bigger. This side is smaller, this side is bigger. So this is the formula. When we have more than one substance, you use the law of conservation. That means you equate the sign. But if it's only one substance, it's only Q equal to MC delta T. Let's look at the second slide. Next slide. It is the example, the past question paper of April 2022. You are given the 3 pieces of steel. So the number of pieces of steel is 3. On the given side, there is steel. Number of items is 3. And the mass of steel is 4 kg. The temperature of steel initially is 150, but it's dropped in 20 liters of water at 25. So steel is going to lose heat. The given temperature will be bigger than the final temperature. So this is T2 equal to 150 degrees. Water, liters are equal to the kg. So mass of water is 20 kg. Temperature of water initially is 45, but once it is mixed with that steel, water is going to gain. That means it will end up having a temperature that is more than 45. So 45 will be T1 for water because it's smaller temperature. And the common temperature is T, is what we do not know. Question says calculate the final temperature of the mixture. Let's look at the solution. The common temperature is the unknown this side. Also this side, the common temperature is unknown. The formula is Q loss. What is between 2 substances. So we use the law. We cannot use MC delta T for one substance. We equate because we have unknowns both sides. Q loss is equal to Q gain. What is losing is MC with open brackets is T2 minus common temperature is T. This side will be MC into bigger temperature is T minus smaller temperature will be T1. Next step is substitution. The mass of the number of items. So we need to multiply Each mass is 4 kg. So if there are 3, it will be 4 times 3 and equal to 12 kg. So for 3 plates, it will be 12. If it's just a single plate, it is 4. So here we're going to put 12 because the total is 12. We multiply by, we need a specific capacity of steel. Specific capacity of steel, we can use the table. This is the table. Specific capacity of steel is 500. We have steel and water. Specific capacity of water is 4,187. So we can substitute. This side is 500 into bigger temperature is 150 minus smaller temperature is what we're looking for. Equal to mass of water is 20. Multiply by capacity of water is 4187 from the table. Into, we don't know what is the bigger temperature, but it's starting from 45. So the only unknown here is this T. We can remove brackets and make T the subject. When we remove the brackets, this is 12 times 500. Use your calculator to get what is 12 times 500. 12 multiplied by 500 is 6,000. In 250 minus T equal to 20 times 4187. 20 times 4187 is 83,740 into T minus 45. Then we remove brackets. We're going to multiply here. Then 600 will multiply there for you. 6,000 times 150. It is 900,000. 600 times T will be minus 600 T. Is 6,000, right? Minus 6,000 T. This must be equal to, this times this will be 83740 T. Minus, we remove brackets, 83740 multiplied by 45 is 376, 3768300. Next step, we collect the like terms. This T is positive, so if we bring this T over, it's also going to be plus that side. So this is minus. If we bring this one, this side is going to be plus. So it will be 900,000 plus 3768300 equal to 83740 T plus 6,000 T. We're just putting the like terms together. Plus 900,000. So this is 4668300 equal to, we add this side, 83740 plus 6,000. This is 89740 T. Divide both sides by 89740, both sides by 89740. Cancels out, we have T. These are like terms. Then we have T. $8300. The answer is 52.02 degrees Celsius. That is the answer. So this is increasing from 45 to this answer. This will decrease from 150 to the same answer. So whatever value you get for T, it must be between these values. You cannot calculate the common temperature of 45 and 150 and you get a value that is less than 45, because 35 is increasing, it's not decreasing. So your answer will always be between the given temperatures. So not all the questions you'll be calculating the common temperatures. In some questions, you can calculate the mass of one of the sides, or you can be calculating the capacity, which is the type of material. This is how you solve it. So we can look at the second example.